Here's my audience verification. So we've all heard of carbon dioxide and our carbon dioxide emissions, but where's it going and what's it doing? Today I'll be talking to you about the chemical reactions that take place that govern exactly what it does to our world, and the acidification it is performing in our oceans, the effects that have, and the greenhouse gas effect it's causing, warming and changing our climate. Today I'll be teaching you about the invisible poison so that you can better understand what is truly being done to our planet. For me, I'm a chemist, or in training, I'm a student, and in all of my classes, general chemistry to organic chemistry, which is the study of carbon-based molecules, we've covered acid bases and thermodynamics in depth. Those are the exact systems that we will be using to talk about carbon dioxide today. Now, first, I'll be covering the chemical reaction that carbon dioxide performs with water to acidify our oceans. Then I will be discussing what that acidification truly is doing to our oceans, and finally the heat trapping properties of it in the atmosphere. So first, let's discuss our culprit, the reaction that you've all seen before in a glass of fizzy water. Carbon dioxide in the air reacts with water to form carbonic acid. Now, this is an equilibrium reaction. The Oxford Dictionary defines equilibrium as a condition of balance between opposing forces. That's what this is. It finds a middle ground. The more you have on one side, the more it flows towards the other. The more carbon dioxide you put in the air, the more carbonic acid gets put into the water, and the reverse is true. The lower amount of carbon dioxide in the air, the more comes back out of the ocean. And thus, that is what happens in your glass of fizzy water. You have so much of it in the glass that it's coming back out. And the NOAA, the National Oceanic Atmospheric Administration, has found that 31% of carbon dioxide emissions globally are absorbed by the ocean. 31%. And so now we know how it gets there, but what does it do? Carbonic acid it's acidifying the ocean, and it's killing everything that is depending on the alkalinity, the non-acidity of the ocean. Namely, anything that has a shell. That's from shellfish to coral to crustaceans. That's all made out of a basic material, calcium carbonate. Now, acids and bases, they don't mix well. If you've ever mixed vinegar and baking soda, you know what happens. And I bring vinegar up because the pKa of carbonic acid is 3.49 found by PubMed Chemical, which is part of the National Library of Medicine. And that is a measurement of acidity, and that measurement puts it as more acidic than vinegar. And the Miss Napolino for the Marine Executive News has stated that the oceans have increased in their acidity by 30% since the beginning of the industrial age. So that's visible evidence of the acid being added to our oceans every day. Now there's still 70% of that carbon dioxide left floating around in the atmosphere. And what's left of that? What of that? Well, the greenhouse gas effect is something that carbon dioxide does quite well. And it is trapping heat on the planet. But, it's winter currently, and lots of the world is covered in snow. So where is all that heat going? It's going in the ocean. 90% of the heat trapped by the carbon dioxide emissions we've made has been absorbed by the ocean. 90%, and that's found by a study by the United Nations. Now, a 2.3 Fahrenheit increase in global temperatures has been found, and this is by Ms. Ritchie and others for Our World in Data. And that is not uniform. Even in some places, it's up to 9% increase since the industrial age began. Now, a 2.3 global Fahrenheit increase is what we're at. A 2.7 increase is where we would end up showing massive consequences predicted by CBS News, or a study they were speaking of. This study listed that a 2.7 Fahrenheit increase, which is only 0.5 of a degree more than what we're currently at, would likely see the collapse of the West Antarctic ice sheet, and that would raise the ocean levels by meters. It's a lot of ice. And so, well, first I discussed the chemical reaction that governs how carbonic acid is formed from the carbon dioxide emissions we did. Then we just talked about the ocean acidification that's causing, and finally the trapping of heat in our skies and seas. Now, the UN called the ocean the world's greatest ally against climate change, and they're right. It's saved us from all the devastating effects that we would have already seen. But an issue with that is, if you're not seeing it, a lot of people aren't too keen on acting on it. And so, our oceans are suffering in the process, and the more carbon dioxide they absorb, the less they're going to help us absorb in the future. They've already shown a decrease in that. Now, knowing what I've told you, should we wait to care about our emissions till the ocean is acid, barren, and can no longer protect us? Should we wait to see until the full force of the damages we've truly caused? Should we act now?